In this video, we break down the solution for challenge number 12, privacy of Ethernaut CTF. This is part of a series of videos that solves all the challenges in the CTF. So if you like this kind of stuff, you are in the right place. And I explain also the reasoning behind the solution so that anyone can understand what's going on and learn from it and do it on their own. So hello and welcome. My name is Pedro and this is the DecentraWise channel. Here we share all things Web3, blockchain, development and security. So yeah, this is the place to learn stuff. So without further ado, let's move on. So we are at Ethernaut CTF page, and in this page we have all the challenges. And what we will be doing today is the challenge 12. So we have MetaMask connected. So we did all this already. So if you are not sure how to do this, or if you have any problems, go to the first video in this series, and there we explain everything and also help you solve some problems that might happen. Okay, so in this challenge, what we need to do is to choose the challenge, the number 12, and open our console. And there we are. We have our challenge ready for us to play with, right? So what do we need to do in this challenge? So we need to unlock the contract, right? The contract should be locked, and there are some private data in it. And they say that the creator of this contract was careful enough, was he, to protect sensitive areas of its storage. Right. So first things first, anything that you store in a blockchain that is not encrypted is public, whether you can access it directly or if you have to do other kind of stuff, anyone can access it, always. So never forget that, right? So we have our contract. They have a bunch of stuff that they don't show. It's not important. And what we need to understand is that there is this storage here, right? And there is a constructor that stores data in this entry here, data. And to unlock it, we need to use a key, right? That is stored in data. And so we need to know what the key is, right? So how can we do this, right? First of all, we need to understand, let's get our instance and try start inspecting our contract. So get our instance, approve in MetaMask, we go, we have our instance, there we are. And now let's check what we have in the contract so we can get the locked value. So let's check it. So it is locked, great. So we can also check the ID is public and the rest is private, right? So if we do ID, we should have something. Let's inspect it properly. So we have a timestamp here, and then the rest of the things are private. And how can we access that kind of stuff, right? We need to use get storage at. So how do we do it? We do await Web3, our interface to Ethereum. So ETH and get storage. There is our function, right? And to use this, we can pass it the instance, right? And we can pass, for instance, we checked locked and ID. So locked should be on storage 0, right? Let's check. Yeah. So, and it's empty. It only has one boolean, which is true. That's why we have a 1 there. And the next, all the slots on the storage of a contract are organized from top to bottom, right? And Ethereum virtual machine packs everything, or the compiler packs everything into 256 bits slots. And if this is a 256 integer, unsigned integer in this case, it will occupy an entire slot, right? So this one, the boolean on the first slot will stay alone. That's why we have all these bunch of zeros before it. And if we check the next, this one, the storage one, we have this hexadecimal number, which is probably the representation of this value, the ID, right? And it's its own storage slot as well, 256 bits. Now we should have 8 and 16 bits all in one slot, right? Let's see. So we have this data. So 0A is 10, FF is 255, this, and the timestamp in Uint16 should be this value, 16 bits, right? D0BC, which is D0BC, as you can see, the same thing. So this is our organization for these three values, right? Now we have bytes 32, 3. So we have three elements of bytes 32, right? And so 3 slots. And what we need is the slot number 2, right? Of these 3. So let's count. We have one slot, 0, the index 0, and then the index 1, then index 2, and the first slot of this will be the 3, right? See, 0, 1, 2, 3, right? So then we need 4. The fourth is the address 1, and the address 2 in this array will be the 5th, right? So let's inspect that. So we have the 3 should be the first element of that array. It contains stuff. And the 4th should be the second element of that array, which is the index 1, right? And the 5th should be the index 2 of that array, which is the third element. So this is the element that we need, okay? So now what we need to do. So we have this value, but we just need part of it, because we want bytes 16, not bytes 32, okay? So we need to cut this in half, okay? So, and we should cut the first, the last part of it, right? So, no, the first part of it, right? We should cut from the beginning to the middle, right? Of this value here. And because it's the way this conversion works. So we have a big number, which is 32 bytes. We just need the 16 bytes of the first 16 bytes of that number. So let's do that. We need to count a little bit. So string. So what we need to do is to await contract dot unlock, and we need to pass something here, okay? This is a byte 16, so we need to cut it in half, cut the last part out. 1, 2, so it's this part that we need to cut out, okay? And now we can unlock our contract, hopefully, because this is the key. Can we try that? Let's do it. Boom, confirm in MetaMask, and we have a transaction receipt, and it went through, right? So let's check the locked status. It's unlocked, right? So what we did was to count the storage, understand where the information was, get it from there, and we are good to go. As you can see, it's not a very big deal accessing any storage anywhere, right? So let's check that we won this challenge. There we go. Confirm in MetaMask. And there we go. We made it, guys. We made it, right? So this is it. Always rely on encrypted stuff if you need to hide things, because just putting them private as you watched doesn't mean that no one can access it. Everything is public on a public blockchain, right? So encryption is there, and we can use it, and that's the way to go to store stuff that we shouldn't be accessible to third parties, right? Also think that storing private things encrypted in a smart contract that the smart contract itself needs to access doesn't work, right? Because if you need to store an encryption key to decrypt the encrypted stuff, the encryption key should always also be possible to retrieve, right? So that's something that we should not rely on either, right? Even contracts can store encrypted information that they don't need to address, right? It's there, and nothing else, right? Or hashes. If you have some way to, if you need something to be stored, but you don't want people to know what it is, why not storing an hash? And that's it. And you can prove that you know what the thing is without having to pass it through in a blockchain, right? Because also if you pass the value, even if you compute the hash on the contract, that information will be somewhere stored in the blockchain. Because when you call a function, that function will be stored in the blockchain forever. So the parameters for the function are there stored also. So don't rely on any of this. Always think that anything in a public blockchain is public, and it's easier that way. Okay? So hope you learned something. And if you did, you know what to do. Just press that like button and subscribe for more, because we are sharing videos all the time. And see you in the next episode, guys, in this series. Cheers. Bye-bye.